This clip we're going to talk about the merit of the majority rule. So the idea is that everyone has a bit of information about the state of the world, and we would like to aggregate those information. And we will show here that the majority rule is a useful tool to aggregate dispersed information within the organization. So now first let's consider the Condorcet theorem. So the setup of the Condorcet jury theorem, imagine the world that you have alternative A and B. One of them is correct, but we don't know which one. So we got n number of voters, and every voter has a probability p of voting right. We will assume that p is larger than half. So every voter has slightly more than half of the chance of getting it right, but they're not necessarily always right. And we also assume that the voters are independent. So the decision rule is we're using majority rule. So that means A win if there is more than half of the vote is given to A. So now let's rearrange this part, which will be equivalent to x. The average vote is larger than half, then A win. We already know one thing that we were able to know is that the expectation of x bar is equal to p is larger than half. So on average, the voter will going to get it right. From this step to this step, we are going to use the law of large numbers. So when n goes to infinity, the sample average will go into the expectation. So actually we don't need the bar here. It's going to be the x, which is larger than half. So on average, people will get it right. So that is essentially what Condorcet jury theorem says, is that when the crowd is large enough, the probability of getting it right is almost the majority will almost surely get it right. The other point I want to make here is for you to notice that essentially notice that if we consider individuals expected voting record, so on average we would expect individual to get it right. However, their variance is going to be, because it's a Bernoulli distribution, it's going to be p1 minus p. The average expectation of average is p, and the expectation and the variance of the average is n over p1 minus p. So when the n is large, the average goes to the true parameter much faster than individuals. So that is the second point of crowd wisdom, is when you aggregate over a lot of people, you tend to get a more stable answer. So that is one way of thinking about the wisdom of the crowd. Now let's look at another way of thinking it, which is what we call prediction market. So the prediction market has the following setup. The market trades a security that pays $1 if the event happened and $0 otherwise. Let's say the event is whether or not Obama will win in 2012. So if he elects president, you get $1. If he does not, If Romney wins, then you get nothing. The security has a price pi, and the security has 0 net supply. So all supply comes from trader who wants to sell. Let's say if you don't believe Obama will win at all, that means you're going to pay $0 on the security. So if you have a security and it has a non-negative offer, bid offer standing, you're going to sell it. And the market will be in equilibrium when all the trader who wants to sell the security at that price. And we assume that each trader has equal wealth y, and they have log linear utility, which allow us to directly transfer payment into utility. Now we are going to solve the market and see what the equilibrium looks like. So the expected payoff is like if the event happen with probability, if you believe with your probability pi, which is the trader I's belief that the event would happen. If the event happens, the net benefit for each security is 1 minus pi, and you get X amount of the money plus your net initial wealth. Now, if the event doesn't happen, which you believe with probability 1 minus pi, basically you get nothing. The payment is 0, and you need to pay negative x pi for the security. So now you are only left with 1 minus x pi. So as all good economists will do, we're going to take a derivative of utility with respect to the demand. So once you solve the first order condition, you get this demand. Demand is the share you want to buy as a function of the market price. So a few things that you will notice that make sense is that the more likely you think the event will happen, at any price you want to buy more. So that's basically the mechanism how we are going to extract information from individual, is that when you when you believe the demand basically reflects your belief of the event, and previously the belief is a private information. There's no way we're going to know, but through the price mechanism we are going to make it public. How we do that? So let's think about the aggregate demand, which has to be 0 because the security has net 0 supply. So we aggregate over all the demand of the system. That's the sum of the individual demand. So demand can be positive or negative. Positive demand means I want to buy, negative demand means I want to sell. And we just plug in, and the total demand has to be 0. The market has to clear at the price. That means nobody wants to buy. The net buy and sell is the same. So now we can show that under the setup, the demand is going to be 1 over summation of pi, which is just the average of the belief. So we are going back to the Condorcet jury theorem, is that we get our average, and the market price effectively reflects the people's average belief about the possibility that event will happen. And from Condorcet jury theorem, we know that this number has a nice property that it will converge very fast to the true parameter, to the true probability that the event will happen. So here in green, I showed you the more general case where people could have different initial wealth. So instead of a simple arithmetical average, we're getting a wealth-weighted average belief about the probability. So rich people has more say, and less rich people has less say. So the appealing part of this prediction market is that it encourages people to reveal their private information through the market price. And instead of getting a 0-1 decision, you're actually getting a nice probability statement about the event that will happen. So that is more feasible and more incentive compatible than the consensus jury theorem. So here we have said a lot of good things about the crowd wisdom. There are two problems that we need to bear in mind. One is that we cannot have common bias. In each case, you cannot have common bias. If the crowd is biased, there is no way you're going to get the true probability that the event will happen. So there's no point of crowdsourcing. The second is that here we have a very nice setup where we only need to decide on one thing, and we can basically do it simultaneously. Once you need to decide on multiple things, or you need to do it sequentially, then you will run into trouble. When you have to do it, when you have to vote over multiple choice, we will have a general setting which will get into a dead loop, and our arrow theorem actually tells you something about that. If you do it sequentially, then you will get into the trouble of conformism or information cascade, which will derail the whole public discussion. So one needs to be very careful about how to organize such crowdsourcing task so as to maximize the benefit of the wisdom of crowd while protecting ourselves against its limitation.